walking when she is 9 feet from the lamp? Does it give it? Oh, it says she is who is 5 feet 9 inches walking towards the lamp at a rate of 5 feet per second. So we need to label a few of these things. So I'm going to start labeling here. What do we have? We have the height of the lamp, right?
Yes.
Let's call this distance what? What do you want to call that distance? Want to call that x? Sure. So what do we know and what do we want? And we might have to label something else in this. What do we know first? What is dx dt? Can someone, not Mark, tell me what dx dt is? Chris?
5 feet.
Careful. Close. Negative 5 feet. Because it's getting smaller, right? And we know also that h is what? Just we know h is what? 23. Now what do we want? Tell me, someone else tell me what we want. What do we want, Noah? The rate of what?
Rate at which the shadow is changing, so like ds.
So we need to label something in here, right? So what do we know? We want to know ds dt when what? When what?
dx dt is negative.
When x equals 9.
When x, how fast is her when she is 9 feet from the lamp? When x is equal to? 9. So this is our picture, right? Do you agree? Nice. We know, we have what we know and we have what we want. What's our next step? Do you remember what the next step has generally been? What do we try to write now? We try to write an equation, right? And we write the equation based on linking what we know and what we want. And in this case, we're talking about linking x and s, right? Do you agree with that? Linking x and s?
Yeah.
How are we going to do that? And more variables? Yes, but in this case you don't. There's a similar triangle relationship here. Can someone, there's a big triangle, right? But we don't want to do the hypotenuse. And then there's a smaller triangle. What's the first triangle that stays? Yeah, what is it?
There's like the little triangle, which is
Yes. So there's this triangle, right? And then where's the bigger triangle? The bigger triangle's already there, right? There's already this bigger triangle, right? So what's the ratio you can write? Can anybody tell me what there's a ratio? So there's something that has to do with 5.75. Yep. So I'll give you want me to give you the first half of the ratio? You know that S over 5.75 has to equal something. S plus X over what?
23.
H. Just do H. We're going to substitute that in a second. So do you see what's going on here? How do you know the triangles are similar? How do you know that this triangle is similar to the big one?
Just inside of it.
Similar triangles have to have certain things that are the same. So first of all, they share that angle.
They have two
right?
angles that are the same, which means
They have two angles that are actually they have all three angles that are the same.
because the
Right?
first two.
Because this angle is the same in both triangles, right? This stays 90, and therefore this one is the same as well. This one's got to be congruent to that one also because what? These two lines are parallel. When you cut two parallel lines by a transversal, the interior angles are the same. Do you agree?
Yeah.
So here's the thing. David did the important next step, which is you can take the derivative now, but you can also substitute in the things that stay the same. What stays the same? H is what?
23.
H is 23. So if H is 23, what do we now have? We have, I'm going to give us more space here, S over what? 5.75 equals S plus X over what? 23. Now we have our relationship between S and X. Our next step would be to differentiate, but maybe before we differentiate, what should we do? What should we do before we differentiate? Yeah, try to simplify. What could we do to simplify this, Arvin? What could we do?
Subtract s.
You could subtract, but when fractions equal fractions, what could you do? Do the cross multiplication. What do you get here? 23s is equal to what? 5.75s plus 5.75x. And then before you differentiate, what should I do? What should I subtract from both sides? Can someone just tell me what 23 minus 5.75 is? 3, 2. Thank you, Andrew. 17.25s is equal to 5.75x. Now what do we take on both sides? What do we take? Oh, Noah, did you say that or Andrew said that?
No,
Andrew, good, yeah. Can someone tell me the derivative now? We're differentiating with respect to what? T, yeah. Tell me the derivative.
Wait, what just happened? Wait. How did you get from there?
Subtracted this from both sides.
Okay.
Can someone tell me what the derivative is? Go. It's not hard. Don't overthink it. What is it? 17.25 times what? ds dt equals what? 5.75 times what? dx dt. And do we know one of those? Which one do we know? We know that this one is what? Negative what? What is it? Negative 5, right? So what do we get here? We now know, we divide by that, we end up with what? ds dt is equal to what? Negative 5 times 5.75 divided by what? Can someone do that on their calculator and tell me what it is? Can someone tell me what it is? Do that on your calculator. This is the rate of change of x. Do you see actually x or s in there at any point? Is x in there? Do you see x in there?
Yeah, that's one.
No, dx is not x. Do you see x in there? No. So the rates of change are related to each other without regard to x.
Okay.
So when it asks this, when it's 9 feet or 12 feet, does it matter how far she is? No, it's always changing at what? Negative 1.66666 feet per second. X is not in the relationship between the rates. It's not there. It is independent. How fast the shadow is changing length is independent of where she is. It's kind of cool.
Yeah.
Kind of cool.
Is that just for this, or?
Yes, it's just for this specific one. Yes. Now the thing is, if it was, there could have been an X in here, right? Like there might have been an X glued on, and would that have changed it?
Yeah.
Absolutely. You just have to plug in X. But in this case, no. Remember in the last one with the rocket ship, you had to find out like what cosine of 45 was? It would be like not having that in there. Okay, erase what you have. Let's do the second one here. I just want a picture of what's going on. You guys can do it too. Okay, so you have a box, right? Water is going into it, correct? And that is, oh my God, that is like a broken box right there, man. I gotta really work on my box drawing skills, right? So the key is, the main issue I'm seeing is people are skipping steps and making it a lot harder than it needs to be. So there is your box, right? What's the base of it? It's 20 by 10, like that. And water is going into it. So I wanted you to actually draw water going into this thing, right? So there's water going into this box. There it is, right? There's water going in.
It's 10 and 12, Mr. Jeff.
10 and 12, thank you. 10 and 12, great. 10 and 12, right? So there's your picture. Do you agree? Arvin, Alex, turn around and watch. We're doing the same thing right now. Arvin, Alex, just turn around and watch. Stop, just pause. So what do you know? What do you know? What does it tell you? It tells you dV dt is what?
20 cubic feet per hour.
20 cubic feet per hour, right? And what do you want?
You want already the rate.
And I don't like that R. Stop using R. So we're going to call that what? Right here. That the height of the water we're going to call what?
H.
H. We want dH dt when what? When what?
When it's filling at a rate of 20 cubic feet per hour.
When B is
I
10
w-
and
Yeah. And B, you know, B is 10, what, 10 and the,
width is 12.
when B is 10 and W is 12, right? Nice. So we want to link volume and height together. You want to link the two rates, volume and height. Agreed? What is the volume of a box? Base times length times height. Which two of those are staying the same the entire time? Which two of those are staying the same the entire time?
Base and length.
Base and length. One is 10 and one is 12, and the H stays in there, and there's V. What do you now do once you have your equation, Alex? What do you do once you have your equation?
You solve. You multiply. 12.
Anybody want to help him? What do you do with this equation now? Find the derivative in terms of t. So what's the left side become? dV dt, because it's changing, equals 120 times what? dH dt, right? Does the question already tell you what dV dt is? What is it?
20.
Is it 20?
Yes.
Is it 20? Okay. So you have,
No, it's 2400.
it's not 20, it's 2400. Did I copy that down wrong?
Yeah, you didn't.
Where's the,
20
no.
is-
Where'd you get 2400 from?
It's the.
That's the actual volume. That's
Yeah.
not. That's the rate at which it's filling.
Yeah, that's what you want.
That's right.
This is right, yeah. You want 20 feet per hour, 20 cubic feet per hour. It's not, where'd you get 2400 from?
2400 is the actual volume of the box.
Of the total pool, but that's irrelevant. You don't,
Yeah.
basically that would just tell you when it would overflow, but it's 20 in this case. So it's 20 is equal to 120 dH dt, right? So dH dt is going to be what? Not dH, dH. 1/6. dH dt is equal to 1/6. And what units is that?
Feet cubed per hour.
It's feet per hour because it's height. The rate of change of height. So one of the challenges here is what's staying the same. The 10 and the 12 are staying the same, but the height is not staying the same. The other hint I would give you is try to choose variables that correlate to the name. So I used R, but it's fine. If you want to call it R, that's fine. I'll track it, but it'd be great if it was H instead. What's the look?